Okay, so hello everyone, this is Akshay here, and let us continue with today's question. Today's question name is anti-diagonal traversal of the matrix. So the question is very self-explanatory, and it's what to say, easy question. Just the complexity is in writing the code. So what you have to do here is, so let's say the given matrix to you is 3 2 3 4 5 1, and let us wrap this very quickly. 7 8 9, right? So this is your diagonal, right? In this direction, but they're saying anti-diagonal, right? So you need to print this one, then this anti-diagonal, then this anti-diagonal, similarly this one and this one. So if you follow this order, this would be your first, second, third, fourth anti-diagonal, fifth anti-diagonal. Just print it. So it would be 3, then 2 4, then 3 5 and 7, then this diagonal is 1 and 8, and then it's 9, right? So you can see verify the output. So, okay, so that's the only thing we need to do, right? Okay, so let us write the code now. So what we are going to do is that you can clearly see that this part can be traversed once, right? And we will use another for loop to traverse this part, right? So let us continue with writing the code. Okay, now please pause this video here and try to code the solution by yourself, and do give it some time, 5 to 10 minutes, and please come back. Now let me show you the code, and then I can explain you, and let me explain you with the code. Okay, so that's the code here. Let me give you a very quick and easy walkthrough. So what we're going to do here, first of all, is that we are traversing the rows at the column, right? The first column to the last. So that's what it's written here. For int c equals to 0 to less than equals to n. Now what we're doing, that let's say, so I'm defining two pointers ij for a particular cell, and let us define it here at this one. So this 2 is ij, and let me remove this diagonal's name. Okay. Okay, so for this ij, what are we doing? For this ij, we are moving here in the diagonally left. So this would be nothing but I plus 1 comma j minus 1, right? And when we will stop, that when our element goes out of bound, right? That we are moving leftwards, but there are no more elements left. And what we can say, that when your j is greater than equals to 0, then only you will get an element, right? That's what we have written here. While j is greater than equals to 0, what we are doing, we are doing I plus plus and j minus, and the index plus plus, we have maintained a new array. We'll push the elements into this answer array, right? What else? So this would be handled again. So 3 would be printed first, then 2 4, and then 3 5 and 7 using this first for loop. Now what are we doing next? What are we doing next is that we are starting from the row 1 and we are going till last row. So there's a for loop here starting from row 1 going till last. Now again, this is my I and j pointer again, right? So ing, how are we moving again? We are again moving till in the same direction, that is I plus 1 and j minus 1. So that's what we have done. But you can see that the stopping condition has changed. Why? Because you can clearly see that there would be one element left in your row, in the column, right? So here we just need to check that your row should be inbound, right? So that's what we are checking. The row is handling by ith variable, so we are checking the row should be inbound, and we just add the diagonal anti-diagonal elements and just return the answer. Okay, again I will repeat, so only complexity in this problem was to write the traversal code, right? And its understanding was very easy. I hope you are able to do this. So let's now hit the submit button. So what is the time and space complexity? Let's discuss that. Okay, so solution got submitted. So the time would be n cross n because we are visiting each and every element, and space would be also n cross n because we're using answer array of linear array of size n cross n. Now n cross n, the constraint here is 100, right? So if you do n cross n, it will be 10 power 4, and 10 power 4 is less than 8, and that is why this solution got submitted. Great. We have done the constraint analysis as well and discussed the time complexity as well. So this is your C++ code. You can take the reference and code the same in your code editor, and you can get the you can compress it to today's GFG POTD in that way. Great. So what else? Great. So that's done. So if you like the video, do like, share, and subscribe. My other social media handle links are present in the description. Do follow it there. And let us meet again in the next video. Till then, keep learning, keep going. Bye bye, and take care.